So we have discussed very clearly about what is big data. So big data is a problem statement surrounding three V's, right? What are those three V's? Volume, variety, and velocity are the three V's with which we define something called big data. Volume, variety, and velocity, right? This volume and variety are linked with, what is that? Storage. And this is linked with processing. So that is what we see in terms of big data. Big data is anything which has got three essential characteristics: volume, variety, and velocity. So this being a problem statement, we have a solution to this problem statement in the form of Hadoop. In the form of Hadoop. So when I use a term called Hadoop, I said very clearly, it implicitly means both, what is that? Hdfs and MapReduce. We have Hdfs and MapReduce. When I use a term called Hadoop, I implicitly mean Hdfs and MapReduce. So this Hdfs is going to address your storage problem, and MapReduce is going to address your processing problem. So Hdfs is what we call it as Hadoop distributed file system, and MapReduce is a simple programming model with which we can process the data very fast. We can process the data very quickly. How? How we can process the data very quickly? By processing the data with a technique called massive parallel processing, which we are going to see. But we have understood clearly these two things: what is big data and what is Hadoop, and what relationship exists between big data and Hadoop. Big data and Hadoop. Because whenever you hear the term called big data, parallelly we also hear the term called Hadoop. Whenever we hear the term called Hadoop, we also hear big data. And people interchange these two most often, and they use it as part of their conversation. But we need to have a clarity whenever we are using the term called big data. We need to have a clarity how it can be used. How it can be used, right? So that's the reason why I am talking about these two terms very specifically. So, and then we have understood the third thing that we have learned and we have understood is the Hadoop ecosystem. Hadoop ecosystem. What we have as part of the Hadoop ecosystem? What we have? At the very lowest level, we have data storage, data processing, and then we have data access, data management, and on the top of all these layers, we have something called data analytics. So the ultimate goal of a Hadoop ecosystem is your data analytics. Why basically we are storing, processing, making it accessible and managing all these things, why we are doing, so that your data can be analyzed. Only when you analyze the data, you will be able to get the meaningful information out of it. Otherwise, there is no point doing all these things. Data storage, data processing, data access, data management, and all this stuff, right? I hope you are clear till this level. Now tell me, out of your observation, where we need to start our discussion further. You have done your homework based on the last session, where we need to start our discussion.
We would need to start our discussion with Hdfs.
Wonderful. That's really appreciable. So we need to start our discussion with the data storage, right? Until and unless we store, we will not be able to process it. So that is why we definitely need to start our discussion with data storage. So as part of data storage, what I have shown you before, I think you noticed we have a HDFS, right? We have HBase, we have a mapper, and then we have a S3, and we have these kind of techniques. We have more. Out of all these things, we take up HDFS and discuss this one because of the reason all the remaining what you see as part of the data storage are similar. I don't say they are exactly the same like HDFS, but they are very similar to HDFS. Almost same like HDFS. Right? So that is why if you are able to learn HDFS, other things we can learn easily. Even you go to S3, which is actually from Amazon. This S3 is from Amazon. They call it as simple storage service. And this is called Hadoop database, again an open source project at Apache, which is a structured store for HDFS. Mapper is another type of storage technique from a company called Mapper, which has got the similar, fundamental or similar technique. Maybe their implementation is slightly different. It is all the same, like, a product, same product, but with different flavors. Same product, but with different flavors. Same like this one. Okay. So let us start our discussion with HDFS now. We have concluded, and I really appreciate that where we need to start our discussion. So it is very clear, HDFS. So as part of this, we have already adopted one technique. At the time of learning big data only, I shared with you very clearly that if you fail to understand something on its own, never mind, you apply the technique called divide and rule. That is where I mentioned it to you. I have given you the homework also. If you fail to understand HDFS directly, never mind, learn file system first, then add distributed to that file system and try to understand what is distributed file system. So finally, understanding Hadoop distributed file system will not be a problem at all. Now, I ask you, what do you mean by a file system? What do you mean by a file system? Yeah, run.
But just the file system would be just on our, say, personal computer, just basic file system. I mean,
Yeah, anything is fine. So what you understand from the term called file system?
say, I would say,
No, I
you know,
really appreciate the
from
example what you are given, but what you understand?
from like say from our root system and then the complete file system, so like a directory tree structure. That would I understand like a
You are absolutely.
my like personal file system. Yeah.
So if you see, according to Wikipedia, is used to control how data is stored and retrieved. File system is used to control how data is stored and retrieved. You agree with this statement, Laden?
Yes.
Simple, right? Is used to control how data is stored and retrieved. Suppose if file system is not there, if file system is not there, then information stored on the medium, I mean your hard drive, would be one large body of data with no way to tell where one piece of information stops and the next one begins. You ever come to know that one? You never come to know where some data is starting and ending. I mean, you might have stored your files, right? Maybe you have stored your last session's Hadoop notes. You might have saved in a Word document. We never come to know where that Hadoop nodes has started and ended if file system is not there. So many times we try to understand with this kind of reverse engineering. There are two ways. We take the statement and finally we prove it, saying, hence it is proved. Hence it is proved. We say like that. We prove the statement. Sometimes we take the reverse. And we disprove that one, and then we say yes, hence it is proved. So now we are saying, if a file system is not there, what is the problem? Whatever we store on the media, that is your hard drive, is going to be one large body of data. And we don't have any way to tell where something is starting and ending, or where the next one is starting. So with this, you have understood what is file system. So you have any question on this, please let me know. I will try to explain you. So any question on this?
No, I'm clear now.
Wonderful. So if you look at that, look at this one. a fat model. I think you remember and recollect from your earlier days. FAT, file allocation table. You remember that file allocation table? FAT is a kind of file
FAT
allocation table. You remember?
FAT 32 or FAT 16 used to be, right?
Ah, you are right. You are absolutely right. Your FAT 8, FAT 16, or FAT 12, FAT 32. Yes, you are right.
Yes,
That is
yes.
what? The file allocation table. If you take that file allocation table model or a file system, how it is being organized, how FAT is going to organize your storage, have a look at that. So what you see and understand from this diagram, that is what your storage media, nothing but your hard drive. So your entire storage media is uniformly divided into blocks, each of fixed size. That is why we are calling it as uniform blocks. I think you notice that one from the diagram. So your entire data, your entire storage on the media is divided uniformly into blocks. Each may be of 4 KB, or it could be 8 KB, or it could be 16 KB, or 100 KB, or 1 MB, 1 MB, or 100 MB. So if you see this one, what is the advantage of keeping the block size to be small, and what is the advantage of keeping the block size to be big? Can you guess that one?
If we keep blocks smaller size, I guess they're faster to access.
Faster access. Okay. In what way you say that one, Vladan?
If you wanna, yeah, I mean, I understand the data is divided into blocks, so each block
Yes.
contains some information. That's what I thought. So
Yes.
maybe if you want to access like a part of information or whatever, if it's the smaller size block, the smaller size, I would guess that it's faster to access the data, to
Yeah.
kind of retrieve it, actually.
Yeah. I really appreciate. If it is a smaller size, if you store a big file, not just a big file, very big file, not just a very big file, is a very, very big file, not just a very, very big file, if it is a very, very big file, then the number of blocks that are needed to store increases. You agree? Say,
Yes.
my file size is 4 TB. You know very well, 1024 bytes is 1 KB, and 1024 KB is 1 MB. 1024 MB is 1 GB, and 1024 GB is 1 TB. So 1024 into 4 GB equals to 4 TB. I mean, it is like 4 1 TB hard drives put together. your size. If my file size is of 4 TB, then imagine how many number of blocks I need to store. They run into millions, right? I need millions of blocks to store my whatever. I mean, I'm not going into the calculation and telling you, but definitely will run into millions. I need those many blocks to store my file. When the number of blocks going to increase, the number of blocks going to increase, the manageability is going to be a challenge for me. Then, in that case, if I go for a 100 MB block storage, the number of blocks will be, it is a simple thing, right? You have 25 people working under you and you have 250 people working under you, 2500 people working under you. How difficult it is going to be to manage. Of course, we have a system where, under you have supervisors, under supervisors you have employees. When the employee strength is growing, and supervisors will be working under managers, where managers will be working under you. More it is growing, then we'll be having senior managers, under senior managers, junior managers, then supervisors, then employees. Still growing, then probably we'll have directors. Still growing, then we'll have next level of hierarchy. We have a way to manage that one. But if you observe closely, under any person in this organization, if you see, under any person, ultimately, there will be only limited people. Maybe under the organization, we may have 2,500 people, but under you, how many are there? Only 10 or 20 people. You'll be always managing those people only. You'll not be managing all the 2,500 directly. Indirectly, you may be managing. So if you look into this one, when the number of blocks going to increase, the manageability is going to be a challenge for me, because I cannot apply that hierarchical model here. All the blocks must be managed by me only. Right? It is a linear here. It cannot be hierarchical. I hope you understand what I am trying to share with you. Now, if I keep my block size to be 100 MB, then even I create a small file, any file I create, I get a minimum block size of 100 MB, where most of my memory is going to be wasted. You know very well, when I create a Word document, a new Word document, its size will be around 2 KB or 3 KB, something like. Let me show you. And you have something called big data, and you see here what is the size of this file is 5.68 MB. Now only for your understanding, I am trying to create a new Word document or a new text document, that is with the name called temp.txt. What is its size? 0 bytes. 0 bytes. Observe very closely here. Observe. I open this one and I type something. 2, 4, 6, 8 characters I typed. I saved it and I go and see now. What is the size? What is the size now? Tell me what is the size? 8 bytes.
8 bytes.
But if you see, the size is 1 KB it is showing here. You notice that? You notice here under size 1 KB.
Yes, that's
Yeah, I mean, same like you observe, I create a Word document, new Word document. It is 0 KB now, but I open this one and I only press one letter. I save it. Now, what is the size of the file, Laden?
It shows 14 kilobits, but that's probably the block size.
No.
The actual file should be smaller.
Yeah, block size is one thing I definitely agree. But you see closely, every file not only contains your actual data, it also carries metadata.
Oh, okay, yeah.
And you open this file with Notepad, I assume. My actual data is A. Somewhere it is there. But all this is the metadata which your Microsoft Office only can understand. Of course, OpenOffice, whichever application understands .docx, it is information to that. Are you getting my point what I'm saying here? All this
Yes.
information, whatever you are seeing here, all this inside your .docx is actually the information to the tools like your Microsoft Office or OpenOffice to open this document and show the content inside, because you know very well inside your text file, plain text file, no formatting can be possible except bigger font or something like that. No formatting is possible. But in Word document you can have italic, bold, different size, indentation, and you have your superscript, subscript. You can insert symbols, keep image, whatnot. Everything can be done through your Word document in terms of the storage. So every paragraph that you are keeping inside your Word document, the meta information about that paragraph or that sentence should be maintained within the document. So when you open it, I'll be able to display all that cosmetic culture what I developed against the actual data. That is why your metadata gets accumulated along with. Of course, this is out of our context, but why I discuss this one, I want you to understand whenever I create a file on my file system, it occupies a minimum size. How that minimum size is being taken into consideration based on the block size. So coming back to this discussion, I want to store a file called file A where I need 3 blocks to store that one. Then if it is a file allocation table model, then I got the blocks starting with 2. 2, 3 and 4 are the blocks assigned for your file called A. So this file allocation table, that structure is storing the information about what is the name of the file and where the blocks starts and what is the length. So that what I understand, tomorrow if I need that same file, I can go to this file allocation table and get what is its start and what is its length. Then I can easily come to know, oh, this is a start and a length of 3. So 2, 3, 4 belongs to the file called file A. Right? Though your file A requires exactly 2.5 blocks. Imagine the block size here is 4 KB. Imagine, I don't say that, but imagine the block size is 4 KB and my file A size is 10 KB. Then tell me how many blocks I need?
You would need 3 blocks.
Ah, you are right.
But
Though
the third block
I
won't be
actually,
used all the
yes,
way. Yeah,
yes,
2.5, yeah.
I actually need 2.5 blocks, but I cannot get 2.5 blocks. That is a problem here. I actually need 2.5 blocks, but I cannot get 2.5 blocks. That is why, because blocks always can be given in a or can be allocated in a whole number. Blocks always can be allocated in a whole number, not in a fractional mode, like 2.5 blocks, 2.75 blocks. No, not possible. Either 2 blocks or 3 blocks. Why I'm discussing all these things? Why I'm discussing all these things? There is a great reason. As our intention is to understand HDFS, we are talking about file system. What file system fundamentals? Same fundamentals will also be applicable to distributed file system, also applicable to Hadoop distributed file system. Maybe the block size may vary from file system to file system, but every file system is block based only. So what we learn the moral from this one, even if you go to HDFS, Hadoop distributed file system, it is also block structured. It is also block structured or block oriented. There also will have blocks. Maybe the size of the block is in the range of 256 MB, 512 MB of that level, because we are dealing with big data. Data will be very big. So rather than going with a small block size, good that we go with big block size. But ultimately the concept of block is the same, right? So that is the reason why the fundamentals, what we are learning now, are applicable even to your HDFS. You got it?
Got it, yeah.
Now see, I want to store a file B and I need 5 blocks. So it is storing like this. File B, whose start block is 9, length is 5. So it is shown with a different color. I think you see that in the diagram here. File C, the start block is 18 and a length of 8. Absolutely, we are happy with this one. This is called file allocation table with a continuous or contiguous file allocation model. What do you mean by this contiguous file allocation model? All the blocks that belong to a file are available to you in the contiguous fashion. I mean continuous fashion. That is why we call this as a FAT model, but specifically contiguous file allocation model. Now, you may ask me one thing. What problem? What is the problem, Srinivas, now? Why you are talking so specifically? Now, I want to store a file. Observe here, Laden. I want to store a file F for which I need 5 blocks. Is it possible now or not? Understand my question?
No, you won't be. I understand, but you won't be able to store over here.
Why?
Because you only have 3 blocks available, so the file system is full. The memory is full.
No. There are 4. No, I said 5 blocks. See.
Okay, but you have 5 blocks available. Okay, you don't have. I don't think it would be possible. I mean, that's just my opinion. I never really studied this file allocation table, but like you don't have 5 blocks next to each other.
Ah.
I mean, I don't know if they have to be next to each other or,
Yeah,
but in my opinion,
you're absolutely
in
right
my
here.
opinion,
Yeah,
in my opinion, wouldn't be possible. I don't think it would be possible to store.
absolutely not possible because overall, if you see this entire storage, we have more than 5 blocks. Overall, if you see, we have more than 5 blocks. Empty. I'm talking empty. Okay. But 5 blocks continuously we don't have anywhere. You take 5, 6, 7, 8. We have continuously 4 blocks, but we don't have 5. 14, 15, 16, 17, 26, 27, 28, 29. So your contiguous file allocation model is going to limit, is going to throw a limitation, because you may ask me one thing, Srinivas, what happens, why the storage needs to happen like this? Why can't it be file A from 2 to 4 and file B from 5 to 10? You got my point? Or 5 to 9? Why it is not happening? Because maybe initially when you store it may happen, but in between I deleted some file. Again, at least the blocks will come in between, right? Maybe initially when you stored, all the files are one after the other. I mean, all the files, I mean blocks indirectly. All the blocks are continuous, but over a period of time, you will be deleting some files, adding some other files, deleting, adding. At least as a part of that process, you see some blocks left in between, not been used. Those blocks will become useless to me. Those blocks becomes useless to me with my, what is that? The storage usage becomes inefficient with this model. That is why we need same fact, but we need compaction periodically. We need an additional feature. When we do disk compaction, I don't know whether you experience this anytime or not. Of course, in the today's modern storages or file systems, you don't have these challenges. It is been automatically taken care. But sometime back, if you might have used Windows, there is an option in Windows called disk fragmentation. You experience that anytime, Laden? Disk
I know for the
fragmentation.
function. I know for the function this fragmentation, but I never used because
So what?
it's usually done automatically.
Yeah. So that disk fragmentation, what it is doing, nothing more, pushing all your data to one corner of your storage, so that the empty space will be at the end and utilization becomes more. Retrieval also will be very fast compared to the data spreading across your hard drive. That is why periodically we will be doing disk fragmentation, so that all the data will be pushed to one corner, and all the data pushed to one corner, and the leftover space is at the end. Now see what is happening here. Now tell me, if compaction is done, can we able to store file F now?
Yeah, now we're able.
Ah, so I think you
Now we have
understand.
5 blocks consistently. Yeah.
Yeah, so it is the same fat model now, but it is after compaction. After compaction. Okay. And still, I see here, if you see closely, I want to add some content to my file A. I want to add some content to file A. Tell me whether it is possible or not first. Is it possible to add content to your file A?
Let me see. The starting block is 0, length is 3. Okay, no, if you don't have, unless you show me the previous case, when you have like a 2.5 actually blocks and then you have some space left, I guess you would be able to add. But if it's all 3 blocks taken, if they're all 3 blocks full, then I don't think you would be able to add.
But if I'm not able to modify my file, that is not called as a file system at all.
No.
Right?
You should be able to but you should be able to modify your file.
So what is going to happen? If I want to store some additional content to my file A, then probably all the 3 blocks which are there, this entire data needs to be copied into the new location somewhere, plus I get additional 1 or 2 blocks, so it is something like copying that existing data to a new place and append the new data, and all will be together at one place, and then I delete my old one and the new one becomes the current one. You got the point?
Got it. Yeah, so data actually moves around.
Then what is going to happen? My first 3 blocks will become empty. Like this, over a period of time, what happens? We experience the earlier one. This one only we experience. Then what is required to be done on the file allocation table and the FAT model? We should apply compaction. So initially when they developed this one only. Then they realized, oh, what are the problems with this one? Then they've added the technique called compaction. As a result, we got the same FAT, but we got this kind of approach. So periodically we do compaction so that memory utilization can be done effectively. You got the point, Vladan?
Yes, got it so far.
So what is the limitation with this one now? The limitation with this one is I want to read the data of a file. I want to read the data of file C, which has 8 blocks. Out of the 8 blocks, I need some content, whether I like it or I doesn't like it. If I want to read the content of my 7th block, I like it or I doesn't like it, I must go through all the stuff linearly. And moreover, the data must be stored in the continuous fashion only. As a result, memory utilization cannot be done effectively and I need to do frequent compaction. Frequent compaction is needed. If I am not going to apply compaction, though memory is available on your storage, it cannot be utilized by you because we need contiguous allocation. That is why I modified my FAT with a new thing called chained allocation. What is advantage with chained allocation? Same FAT, start block is 1, length is 5. But the address of the next block is being stored in the current block. Its next block is stored in the current. Its next block is stored in the current. So we will be able to use the memory effectively now in this case. You got my point? Two problems we have in the before implementation. One, I am not able to use the random blocks inside my storage. that is been solved now. But still, even in this case, if I want to reach my fourth block, I must go through 1, 2, 3, then only I'll be able to go to my fourth. I cannot directly go to my fourth block. I hope you are getting the point what I'm sharing here. Is that clear,
Yes.
Aladdin?
Yes.
That is why we have a new technique called indexed allocation, where file B, again it is fat only. You see, all this is fat only. How this file allocation table model has evolved. And then we have NTFS model, where Windows NTFS is your new technology file system, whatever, next generation or new technology file system, where it is ultimately the storage technique, how effectively we store and retrieve. Otherwise, it is going to be a challenge for you. That is why the file system. In the index allocation, if you see, file B, whose index block is 24. So in the index block, I will have the information about all the blocks belong to this file called file B. But what is advantage with this one? The advantage with this one is I can randomly access my blocks. I need not go sequentially now. I can randomly access my blocks. Makes sense, Laden, what I'm trying to share with you.
Yes, I understand.
Now, I need not tell you much about why we require distributed storage. Now, I have explained you very clearly why we need file system. Why we need file system. Why we need file system? Without file system, we will not be able to store and retrieve the data. That is why we need file system. If file system is there, we are able to store and retrieve. So we have seen the file system. One example for your file system called FAT model. When you have this kind of storage, why you require distributed file system? I tell you like this. You are not able to do some work on your own. What you do? You are not able to finish some work on your own. What you do?
Ask for help.
You hire some person, you assign some work to that person and get it done. Right? You hire a person, either you pay or you voluntarily, whatever it is. You hire a person, assign the work, get it done. You have more work, maybe more people you hire, still more work, more people we hire. So, when more work is coming to you, you are never dreaming of yourself becoming more and more strong, robust. Same like, if I have my file or my data which can be managed by one operating system, I'm happy with that. You know very well this aspect. With a normal or naked eye, we can only see up to 100 meters or whatever. or 200 meters. You want to see beyond this? What is needed? You want to see beyond 200 meters. You need a binoculars. But with binoculars also we can see only to certain extent, maybe 1 kilometer or 2 kilometer. Beyond this, telescope. But I am able to see only to certain extent. Beyond that, as of now, I don't know personally whether anything is there beyond telescope or not. But to my knowledge says beyond telescope we don't have anything now. Maybe more powerful telescopes are there, but beyond telescope we don't have anything now. So people are working on identifying what is beyond telescope as of now. So you observe closely this example, you understand and appreciate. You understand and appreciate. What is that? Your visibility is only to certain extent. Same like with the FAT, I mean the file allocation table model, I will be able to manage only some X number of blocks. Beyond this X, I will not be able to manage using my FAT. I go with other one, with other one, with other one. But all your traditional operating systems, OS, able to manage up to 2 TB or 4 TB, something like 10 TB or 100 TB, whatever. Beyond this, your traditional operating systems fail. When my storage need increases beyond the manageable limits of your OS, traditional OS, then what you do? Laden, you got the point? You got my question?
Yes.
When you fail to get your work done, what you are doing? You are hiring one more person and getting it done. When my storage need goes beyond my manageable limit, when my storage need goes beyond my manageable limit, then what I need? What I need?
Hadoop.
No. We need to divide this into two parts. This I store it on one OS and this I store it on one OS. But ultimately both should look like a single storage to me. They may be multiple operating systems, each managing one, but ultimately it should look one unit only to me, not like two units like how. Though we have blocks, but it is one storage to me, not like blocks. Same like, it looks to be one storage to me, but not like distributed storage, not like storage distributed on two operating systems. Such a kind of operating system which gives you the illusion of a single storage, but actually it is being stored on multiple boxes. Some data is stored on this box and other data is stored on this box, other data is stored on this box. Physically, there are multiple machines in the background, but all comes under one storage. That is what we call it to be distributed file system. Now your file system is not centralized anymore. It is distributed across multiple machines. Why this is happening, or why this is coming into picture, or why this concept arises? When my storage need increases beyond the manageable limit of my operating system, I need something to manage this. That is called your distributed file system. You got the point, Vlad?
Yes.
So even if you go to your distributed file system, what should be there inside it? Maybe your storage is distributed onto multiple machines now. Your storage may be distributed to multiple machines now. But what will be there in the at the storage level? See, ultimately, if you go to the deepest level, you have a bit and byte. 8 bits put together, 1 byte. Right? 1024 bytes put together, 1 MB. Are you getting my point? Sorry. 1024 bytes put together, 1 KB. Such 1024 KB put together, 1 MB. So you look closely here. Ultimately, your data is going to be in the form of bits and bytes only. But at your OS level, it is in the form of blocks. Now also what will be there? In distributed file system also what should be there? Laden. In distributed file system also what should be there? Blocks
Also blocks.
only. Size of the blocks may vary, but blocks. But these blocks, instead of being confined to one operating system, now they are being confined to different operating systems running on each host, but all put together one storage only. It is not, maybe actually physically the data is being stored on different machines, but tell me if you go to a distributed file system, I don't know whether you experience this anytime or not. I don't know whether you experience this anytime or not, but if you see closely, I have my CentOS file system. I have my CentOS file system. Now, at my root, I have all these directories. At my root, I have all these directories. At my root, in my file system, I have all these directories. Right? Now, this is a CentOS operating system, which is like your fat only. Okay. So when my storage need goes beyond this one, I go for distributed file system. Now tell me, even if I go for distributed file system, what should be there? Whether it is a distributed
Blocks.
file system or a file system, it is all the hierarchy only. So what should be there? Even for the distributed file system also, there should be single root only. My pain of giving you all these things is to make you to understand. Even if you go to, if this is your CentOS, you have a root. We have a distributed file system, then also we have a root. Even you come to your Hdfs also will have a root. But in the background, if you see only one machine, inside the machine we may have 2 hard drives. But in this case we have multiple machines, each may be having multiple hard drives. This is 1 TB, this is 2 TB, and this is 1 TB. So altogether 4 TB storage here, and here this is all 2 TB, 6 TB storage we have here, and these are 6 TB storage we have. As my need is beyond my traditional file systems, I am going with my distributed storage. But even if you go to my distributed storage, like how you are seeing here, how you have ls-al, you say /, nothing but the root, how it is showing you the file system under root. Even if I go to my distributed file system, there also I should see root only. Though we have multiple systems in the background, But all that storage put together, one storage only. Physically, we may have machines, but logically, all that comes under one storage only and one file system. That is called distributed file system. If you fail to understand this distributed file system, please let me know. I will explain you in a different style. You understood the distributed file system?
Yes, I understood. So we practically open up, we only see, if you open up a terminal and see like a one file system, it doesn't matter if you have like a 4, 5, 10 hard drives underneath.
No, not
It's
hard
all,
drives. Not hard drives. That is your
I mean,
synchronized file
file
system.
system, file system, sorry, file
No,
system.
not file systems. Machines.
Machines. Okay, that should be like if we have a cluster of computers, then we still see one file system,
You got the point.
right?
All that cluster will have only one file system. Like how your CentOS has got one file system, your cluster also will have one file system. That file system is called distributed file system. You got the understanding now?
Yes.
So this transition, if you are able to understand why we are moving from your normal file system to distributed file system, this if you are able to understand, you are done. You can easily understand HDFS. Now as I told you now, ls-al, and I have given root. At root we have this. Observe, Laden, please observe this one closely. Now, what I'm trying to do is, I'm trying to have a look at this one. Please look at this one. Now, Hadoop fs-ls / I said. What is that I got? What is that I got? Please compare these two things very closely. This is my normal, whatever I'm showing you this side, root at eBiodata, root at edge node, two terminals separate. Root at eBiodata is my, what is that OS name? One second.
No, try uname.
Uname, yes, you're right. You're right. Uname. So what is that?
Linux.
Right? Linux flavor, CentOS or whatever it is, Linux flavor.
So if you
So,
want to see, you can do uname minus a, I guess. Uname minus a.
yeah.
Yeah, that's what give you. But still, you just give you the kernel and.
Yes. The kernel
There
details.
is there is an option to show you the exact operating system if that's what you're trying to do, like Red Hat or CentOS or Ubuntu or.
Yeah. How to find OS name in CentOS and Linux, whatever. Okay.
If you name minus, just I forgot the option.
Yeah, that's true. So uname minus hyphen a, it is saying something. What is
Or
it?
you can go to Etsy directory or
Yeah,
see the
uname
configuration
minus
file.
a, and okay.
Oh, LSB, release minus A, yeah.
LSB
Underscore, yeah, underscore release.
yes,
Minus A. No, I don't know.
but
There should be on Ubuntu. No, it's not that.
slash it is not showing. Cat slash etc slash there should be something called release or Red Hat.
Yeah, because CentOS and Ubuntu are different.
Yeah, that is true. Because there is
Very
slight
different
difference.
commands.
The slight difference you see here. Now you are seeing this one. Got it?
Yes.
What is the operating
Yeah,
system
got it.
saying? It
CentOS
is CentOS
6.9.
release 6.9, right?
Yes.
And you see here, Laden, this is my Hadoop distributed file system. That is why command is slightly different. Hadoop FS, and then we are using ls and giving forward slash. That is root. So at your HDFS root level also, what we have? Under root we have TMP, user, datasets, accumulo. All these are there under your root. You are getting my point? Hadoop
Yes. So
fs-ls slash tmp if I give, then I should be able to see all these things. Under tmp I have all this stuff. But if you see closely, all these are like how we are seeing here, ls-al forward slash, like root is the user and the group to which he belongs. Same like here, what is that? Are you seeing? Are you seeing? Anusha? Yeah, sorry, Ladan. Yeah, what you are able to see
no
here,
problem.
what you are able to see in the Linux or CentOS, similar thing we are seeing in HDFS. So, what you understand from this one is, both are file systems only, and this is your normal CentOS centralized file system where all the data is managed by one operating system. But here if you see closely, this is my Hadoop cluster where I have 7 nodes in the background. But are you feeling that there are 7 nodes here, Laden?
No.
Hadoop.
I just see one file system.
This illusion is what we need to understand. If you are able to understand that one, many complex things that you come across in the coming days, you can easily understand. Most people, the biggest challenge is to understand and visualize this distributed file system. They will say, hey, Srinivas, there are 5 systems in the background. What is a file system on that? Though we have 7 systems or 70 systems or 700 systems, all put together only one storage. One storage will have one file system. So, how many file systems Hadoop will have? One file system only. Like how Your CentOS has got one file system. Hadoop also will have one file system. How to access that file system? Hadoop FS-ls. You are accessing that. Like how you are accessing this file system as ls and forward slash. There we are saying Hadoop FS-ls and forward slash. Now I think you are able to understand here very clearly. Is there any challenge?
Yes, and now once we're in the file system, we can use commands to manage as a single file system.
Exactly. Like how you are managing the files here, you are able to create files. See, management means what, Ladan? Ultimately, storage management means what? Not only these things. Storage management means what? CRUD only. What more we have? Against any storage, we can only do CRUD operations. What do we mean by CRUD operations? Create, retrieve, update, delete. What more are possible? Tell me. Either we can create or retrieve, or existing one we update, existing one we delete. That's it. We create a file, we retrieve whenever we want, we add something to that, we delete something from that, and we delete the total file or directory itself. We don't have any operations beyond this. So all your file system commands revolves around this CRUD only. Different ways to create files, different ways to retrieve files, different ways to update files, and different ways. It's all based on your need and the convenience that been provided. I hope you are following with me what I am sharing with you here, madam. You think I am successful in making you to understand HDFS?
Yeah, I do.
That's great. I appreciate. See, ultimately the goal of this training is that you need to get the concept. That's the only goal. No other goal, right? You should get the concept. How you got the concept, either with your effort or with my effort, is different. Whether we know it or not. Just before this session, you are not aware of certain things. Now you are aware of many things. Simple. And over a period of time, you will become aware of many things. Okay. So it's all an improvement day by day, and over a period of time we see considerable improvement. At a granular level, we may not be able to see much improvement day by day, but over a period of time we notice that what is being improved in our skill set. Right? So you have any questions to me, Laden, please let me know. I want to clarify all those things before I take you to Hdfs architecture and all those things.
No, I'm clear with this.
Wonderful. I appreciate. So one thing I would like to really appreciate, maybe I don't know what homework you have done, whether you have done the homework before coming to the class or you have the ability to understand the concepts fast. I don't know, but I'm really happy the way you are receiving things. See, whatever I'm discussing now, are these new to you or you already know all these things, whatever I'm discussing?
No, I don't know. Hadoop is totally new to me. I never used it before.
No. What are the concepts I'm talking now? File system and all these things, what I'm trying to teach you. All these, are you aware before or you are learning, you're trying to understand now?
No, I wasn't aware what you're going to talk about, but I was familiar with the file system and mostly with Linux.
Yeah, but I don't think you have the understanding at the level what we discussed today with these kind of diagrams, right?
No. I wasn't aware of that.
Yeah, that's really good, Laden. Take any file system. let it be Linux file system or any file system on this planet, it has got the same fundamental principles. Slightly may here and there you may feel different, but ultimately the concepts are the same, right? Block is the fundamental unit. Okay, depending on the type of the operating system, we may have different sizes. So even when you come to your HDFS, what we have here, now to see this diagram. This is my HDFS architecture where I have a number of data nodes. Don't worry, I'm going to introduce all these things. See, data nodes and name node is just nothing but because your Hadoop is completely end-to-end. Hadoop is completely based on master-slave architecture. Hadoop is completely based on master-slave architecture. I mean, when I'm saying Hadoop is completely based on master-slave architecture, I mean, under Hadoop what we have? We have HDFS and MapReduce, right? HDFS is master slave, MapReduce is also master slave. Under HDFS master slave, master is name node, and you know very well, usually in the master slave architecture, there will be one master and number of slaves. You take any master slave architecture, there will be one master and a number of slaves. Even when you come to HDFS, as this being master slave architecture, there is one master that is called name node, and we have number of data nodes. Data nodes are the actual nodes where data is stored. Then what name node is doing? Name node only going to store metadata. I mean, where my actual data is stored, those details are being held with your name node. Those details are being held with name node. So with this you understand this diagram. There is one name node and there are number of data nodes. Inside each data node, what we have? Inside each data node, what we have? What you
We have blocks.
Absolutely. So block architecture is the consistent and the common feature that you see in every operating system or every file system. But the only thing is, when it comes to HDFS, we call it to be higher level of block abstraction. Higher level of block abstraction. Why we use the term called higher level of block abstraction is because of the reason we have usually the block sizes in the range of 32 MB or 64 or 128 or 256 or 512 or 1024, nothing but 1 GB block size. So the range is usually like this. This 32 and 64 are almost gone. Now no Hadoop cluster has got 32, 64 MB block sizes. That is when Hadoop been introduced to the market years back. Now the most common is 256 and 512. And rare we see 1024. But there are clusters where the block size is 1024. So there are questions arise when inside 1024 MB block, nothing but 1 GB block, only a small portion if I use, most of the remaining memory goes waste. That concept always arises. And there is an answer, or there is a solution for that also in Hadoop in the form of har files, Hadoop archive files, like how you have zar files, var files, er files, par files, same like we have har files, har files, Hadoop archive files, where the data of multiple can be stored together. That we'll see about those things later stage. Okay, but Hadoop is a higher level of block abstraction. What do you mean by higher level of block abstraction here? Higher level of block abstraction, I mean the block size is higher, so that the manageability is going to become easier, especially in the case of big data. The manageability is more affordable. The manageability is more affordable. So I hope you are pretty clear now with what we have discussed, and HDFS architecture is going to be very easy for you to understand now, because your HDFS architecture, or in fact your entire Hadoop architecture, is let you go to any component inside your Hadoop ecosystem. Most of these are going to follow or based on your master slave architecture. Master slave, right? So master is name node and slaves are data nodes. When it comes to your MapReduce, master is job tracker and slaves are task trackers. So don't worry, we are going to talk about Hadoop daemons. Okay, at that time we talk about these things in detail. But as we are talking about HDFS, master is name node and we have any number of data nodes, usually in the range of no, normally we plan to set up a cluster with 5 to 10 nodes at the beginning, and eventually we take it forward, and over a period of time your cluster starts growing by adding more number of nodes to it, so that you can address your new storage needs as part of your Hadoop cluster, right? So please go through the concepts of HDFS now. It will be more effective. What is file system namespace? That is there even in your Linux, but data replication is not there. Why data replication is needed only in Hadoop or in Hadoop and distributed file systems? We talk about those things, don't worry. But I want you to thoroughly understand, because visualizing, if you are able to visualize your Hadoop distributed file system, your job becomes more easier. You'll be very happy and you'll be very comfortable working with commands. You feel delighted. I'm not doing anything new in HDFS, just what I'm doing in my Linux in a different style I'm doing even with my HDFS. When you get that kind of feel, learning technology becomes more easier. When you get a feel that it is tougher, you will be thrown out of that. But when you feel it is no other than your same what you learned and used all these years, but slightly in a different style, then it's your mind automatically provokes, get into it, right? So I advise you, Laden, to please go through whatever we have discussed in the today's session in detail on your own, without any external or even my support. Then your foundation, your fundamentals becomes more strong, where that gives you the opportunity to work with your HDFS very closely and comfortably, right? Have any questions to me, Laden, for today?
No, not so far. I mean, I'll just read through whatever we went today and I'll be fine.
That's really cool. I appreciate.